Okay, let's now move on to what are repetition codes. So repetition codes is the simplest possible error correcting code, and under this we have the concept of majority decoding process, which means that for each block of 5 letters, the original letter is the one that appears the most frequently in the block. So we will try this exercise. So we have these messages and the given of repetition is equal to 4. So this means that for each bit, it should be repeated 4 times. And so we have the channel encoding, and we can see that x1 is repeated 4 times and x2 is repeated 4 times. So we try with 0, 0. So we first repeat 4 times of 0. So we have 0, 0, 0, 0, and then another 4 times for 0. And then we have the second one is 1, 0. So we repeat 1 4 times. So we have 1, 1, 1, 1, and then 0 4 times. 0, 0, 0, 0. And then for 1, 1, we have repeated it both 4 times. So we have 1, 1, 1, 1, and 1, 1, 1, 1. And lastly, we have 0, 1. And we repeat it again by 4 times to 0, 0, 0, 0, and 1, 1, 1, 1. So the question now is how will repetition codes detect and correct errors? So have this illustration. So Sean sent a message X using repetition code R is equal to 4. However, Saskar received a message Y that is 0, 0, 1, 0, 1, 1, 1, 0. So the question now is, are there any errors? Can you detect any errors? The answer is yes, there are errors. And the errors is due to, since we are using repetition code, it is assumed that in a bit string, the numbers are the same. So there are errors. But how can we detect and how can we correct errors? So we will correct errors using the concept mentioned earlier of the majority decoding process. So the majority decoding process means that for each block of 5 letters, the original letter is the one that appears the most frequently in the block. So let's have this first block. So 0, 0, 1, 0, it appears the most is 0. So 1 should be 0. And for the second block, appears the most is the number 1. So the last number 0 should be 1. So this is the correct message.